Good morning. My name is Jeff Wade. I'm the team lead for community outreach in the natural resource industries for Esri here in Redlands, California. It's my pleasure to welcome you to this first in a series of webinars organized in concert with the Esri Petroleum User Group Middle East chapter. This webinar is entitled Drone Imagery in the ArcGIS platform. The webinar is being recorded and will be posted in the next few days. As a participant, you'll receive a follow-up email with a link to that recording. I'm confident that many of you will have attended other GoToWebinars in the past, and today we'll follow our normal practice of encouraging you to enter questions as we go along in the GoToWebinar questions dialog box during the presentation.
Good morning. And thank you for joining us today. My name is Ayman Abu Nimri. I'm the co-chairman and technical chair for the PUG Middle East. I work for ADNOC IT as acting section head for upstream, downstream solution. Before I moved to ADNOC, I used to work for ADCO IT for 9 years as a program manager for geospatial solutions. Before we start, I would like to share with you a quick updates about our status as a community. We are a newly established community which aims to facilitate exchange GIS experience between members in the petroleum industry and Esri. We strongly believe the community is the heart of this group. Whenever we have chance, we coordinate social gathering events in the region to be able to network and connect with your peers in this industry. And of course, to share stories about your work and how you take advantage from Esri software. Another key component of this group is to open direct communication with Esri to meet our needs in the petroleum industry, which keep changing over time. Next slide, please. A cornerstone that we look into is to identify the technical tracks. I'm sorry, can we go back to the previous slide? A cornerstone that we look into is to identify the technical tracks which are commonly interested by the community. This webinar, for example, is really special, since it's our first experiment with the help of Esri, trying to introduce new software from Esri requested by the community. If you have any ideas for another technical topics in the future, please do not hesitate to communicate with us. As for the educational tracks, please visit our LinkedIn group, as we publish short training blogs from time to time about different subjects that might interest you. Next slide, please. Let me introduce you to the PUG Middle East Steering Committee. What brings us actually together is our passion for GIS, which drives us to volunteer and spend time and effort helping the community. I would like to take this opportunity to send them my appreciation for all the good work they have done so far. Next slide, please. We are running a LinkedIn group, and you can join us using the link appearing on the screen. All announcements, interactions, suggestions are being communicated using this group. And now I'm going to ask Jeff to take us through the agenda of this webinar. Thank you.
Thanks, Simon. I'm sorry if it seems like the audio quality has taken a little time to settle down. Hopefully we won't have any problems going forward. So apologies for that. So, okay, with introductions complete, let's quickly have a look at the agenda for today. The material we'll cover was born from a question raised by members of the Middle East PUG about the increasing use of drones in the region and the capabilities of ArcGIS to absorb and work with that imagery. The low cost and high mobility of drones enable the acquisition of massive new data volumes, presenting new challenges for processing and the effective exploitation of that data. Our goal today with the webinar is to explore how ArcGIS is being used to support drone operations and drone data management. Specifically, we want to look at how to ingest and process drone imagery and video, of course, using the ArcGIS full motion video add-in, how to build orthorectified mosaics from still frame images using the drone to map for ArcGIS, and also how to process large projects with new ortho mapping tools. So now I'd like to hand over to my Esri colleague, Cody Benkelman, for the main presentation. Cody.
Thank you, Jeff. It's an honor to be here with you this morning and present. I'm a technical product manager on the Imagery team in Redlands, California. So let me go ahead and get started with our next slide. What I'd like to do is talk about drone imagery in the ArcGIS platform, and our approach to imagery is fully supported by the ArcGIS platform. First, ArcGIS has the capability to manage virtually unlimited amounts of imagery content. Our imagery information model facilitates the storage of imagery so that it can be readily found and used for the creation of multiple products, all without reformatting or otherwise increasing storage requirements. Second, numerous analytical tools are available to correct, analyze, and extract both 2D and 3D information products from the imagery. Many analytical tools can be set to operate on the fly to reduce duplication of data. Then, as image services, the original source data and derived products can be displayed or manipulated by various maps and applications created by ArcGIS Online or via runtime applications. This imagery is shared across the platform as Esri image services or as various OGC services such as WMS or KML format. So this is the general imagery story within the ArcGIS platform. And drones provide an exciting new mode of image acquisition. I want to highlight this subtitle as a key takeaway. There's certainly excitement about drone to map and full motion video, and I'll get back to those in a moment, but I want to set the context with a bigger picture. With regard to drone operations, if we look at data management, ArcGIS Online provides extensive content to support drone project planning. Examples include elevation data, property parcels, political boundaries, and weather, among others. Of course, we do have specific tools such as drone to map and the full motion video add-in that are focused on bringing your drone imagery and related metadata into the GIS for long-term management, access, search, and analysis. If we look at analysis, we have many different modes for visualizing imagery in 2D and also 3D. Spatial analysis provides a large number of tools designed for a variety of different disciplines and applications. And we have a new capability within ArcGIS Enterprise that we refer to as raster analytics for scaling your analysis up to massively large collections of imagery. And with regard to sharing imagery, dynamic image services provide access to the full resolution and full content of all image data. Geoprocessing services enable the server to perform complicated operations under the control of the client software, but without requiring download of large quantities of data or having advanced processing capabilities on the client. Of course, we have a variety of APIs for custom applications built by partner companies. And last, the built-in security of ArcGIS is also a very valuable component when implementing the ArcGIS platform if your organization needs to control access to your data. So for me, this was a key realization. Drones are inherently mobile geospatial sensors consuming and generating data. All of that data and decision-making about proximity of different objects and events, and how spatial patterns affect everything in the world in 3D and in time, can be managed, analyzed, and shared in ArcGIS. Okay, that was just intended to provide a bit of a context, but let's look at some of the specifics of drone imagery. ArcGIS has a variety of workflows for ingesting imagery, but it depends on the mode of imaging. Frame cameras will require different workflows and generate different data products as a function of the viewing mode. So for 2D mapping, the sensor generally views downward or nadir. And for 3D modeling, the imagery is acquired at an oblique angle. We're also seeing a great deal of activity regarding close-range inspection of assets, such as cell phone towers, transmission towers, even hydroelectric dams, with imagery captured in a high oblique mode. And of course, still frame imaging is used in different applications than full motion video. So these different modes lead to different workflows and different data products. Within the drone to map software, these imaging modes are reflected in the 3 optional workflows that you'll see when I demo the software. For 2D mapping to create orthorectified mosaics, 3D modeling to create point clouds and 3D meshes, and the inspection mode. And although we certainly want to encourage use of drone to map, I want to make sure to note that if you are working with other software products, such as Drone Deploy or Pix4D or others, ArcGIS can certainly work with the resulting data products. Okay, so that's the end of my PowerPoint slides for this section. What I'd like to do now is go ahead and go into a demo with Drone to Map and show you what the software looks like when you're actually running the software. So on screen you should see my dark gray background for a Drone to Map project. And what I'll do is set up a new project and show how this would work. So I simply give the project a name and then point to a path where the project will be located, and then add my folder of images. And in this case, I've just got a small number of images in this folder, and you'll see the software immediately recognizes the image names and the latitude and longitude. In this case, the GPS is written into the EXIF header of the individual JPEG files. If that data was not available in the header of the image files, then we would have to enter a table of values for latitude, longitude, and elevation. So what you're seeing now on screen, let me change the base map. The imagery you're seeing on screen is just from our base map. So if I go to the topographic base map, it will be less confusing. So the blue dots are actually the location of each individual frame, and then the orange line is the flight path. And what I'm going to do is go ahead and start the processing so that you can actually see how long this project takes to run. And one of the things that I think is very nice about Drone to Map is while the processing is running, the software is still very responsive. So now the software is running and you'll see a progress bar beginning down here on the bottom, but I can go ahead and now show you the processing options that I'm using. So in this case, I'm running in rapid mode, which is intended really for operating out in the field to make sure that you don't have any gaps in your project before returning home. And in this mode, we're going to run and capture what are called key points or interesting points where the software can find contrast. We're using a reduced resolution view. And if the software has any difficulty determining how your flight was conducted, we can give different options for how the flight was organized. The second phase of processing would be to densify the point cloud and create a higher density result. But in the case of the rapid mode, we skip this step and we go directly to the 2D products. And now you'll see in the two-dimensional product menu, I'm creating an orthomosaic. I'm also creating a digital surface model, which will include trees and buildings. And then the software will also estimate a bare earth digital terrain model, although I want to caution that this is not necessarily appropriate for hydrologic modeling. The digital terrain model created by Drone to Map is really a first estimate for a good bare earth terrain. But you'll see I'm actually running at a reduced resolution view in this rapid mode. And again, the purpose of that is to allow the software to run more quickly. In the 3D products, once again, I'm not running these products in my rapid mode, but we can create point clouds in the LAS standard for LiDAR data. We can create 3D textured mesh in a variety of formats. The scene layer package is an ArcGIS format for publishing on the web. And once again, we've got control over the resolution that these settings will run at. The Resources tab allows me to control the number of CPUs that are being used. In this case, my laptop has 8 cores, and so I'm using all 8 for the processing. But if I want this to run in the background while I'm doing other work, I can decrease that setting. And if you ever forget where you stored your data, this is the tab where I can come back and find the folder where my data and project are stored. So that's just a quick view of the various settings. I'd also like to highlight a couple of other particular components of the software. This in the top center is to draw a clip area, and that may sound very simple. What we'll do with this is actually clip the output data products, but this can also be very important if you're ever shooting an oblique project with a wide-angle lens and your imagery actually captures some of the horizon or the sky. This clip area can be very important to reduce the processing area. Another component that's very important that I'll show once the processing is complete are entering ground control points. And you'll notice that I ran this project without any ground control points, but if I do, and the software will run without ground control, but the end result will not necessarily be accurate. It will be in approximately the right location on the Earth, but it's not going to be accurate until I enter the ground control points. And so that's something I'll show with a project that I've got already completed. And last, I'd like to show this sharing section. When I create the orthomosaic and the digital surface model, I can push one single button here and actually publish that as a tile layer. And if you're not familiar with the terminology, the tile layer is the same format as the ArcGIS base maps. So we can very quickly publish the outputs from drone to map in ArcGIS Online. And if I create a 3D output, I can publish this next button is the scene layer button, which is our tool for publishing a 3D web scene within ArcGIS Online. Okay, and I talked just long enough for the software to come back and finish. So that took about 4 to 5 minutes to create this output product. Let me close the control points, and if I now zoom out and turn my imagery base map back on, let me turn off the image points and the flight path. If I turn off my orthomosaic, you'll see that at this scale in our base map imagery, we actually do have an image of this containment pond. But when I zoom into full resolution, that disappears because at our high resolution base map, that imagery did not exist when this base map was created. But if I turn my orthomosaic back on, this is the mosaic I just created in about 4 minutes, 4 to 5 minutes using drone to map. And I also created my digital surface model. So you'll see the digital surface model rendered as a hillshade is also one of the natural products of drone to map. One other thing that I may as well point out is the alignment of this road compared to the base map, you'll note is not perfectly aligned. And again, that is because I did not include ground control. So let me show very quickly. What I'll do now is call up an existing project where I've already run this data. And in this case, what you'll see is I did include ground control. That's these points where the red X's are located. And if I toggle between my orthomosaic and the base image, you should see a much better alignment. So with ground control, we can actually get to just a few centimeters of accuracy. And if anyone is interested in a report on exactly how accurate we can be with drone to map, we have done a test with a surveying company. So now let me jump to ArcGIS Online, and what I'll do is show the example of what that tile layer would look like. So within ArcGIS Online, if I do push that tile layer button, and again that was right here, this will call up a dialog where I can choose to publish my my scene in ArcGIS Online, but I've already done that. And so now here you'll see the result of that processing as a cached base map within an ArcGIS Online view. So I believe that was all I wanted to show with regard to Drone to Map. We will have time for questions at the end, so let me close Drone to Map for now, and we can come back to that if you have further questions. Now I'd like to go ahead and go on. I should mention, you'll see on screen, this data was provided courtesy of Seneca Resources. But let me go back to my slides now and talk just a little bit about full motion video. Full motion video is supported in ArcMap as long as the video contains metadata regarding the position and orientation of the sensor, of your sensor system. So to enable viewing of video on a map or to overlay your map feature data in the video, we provide tools to multiplex raw video with GPS and orientation data to build the appropriate metadata format. And this was made necessary by the explosive growth in drone activities, where most of the drones do not come with the appropriate video metadata format. The specific format of video metadata that we need is referred to as MISB. That's MISB, which is short for the Motion Industry Standards Board. And I can discuss this in further detail after the presentation if you're interested. But let me go ahead and go to ArcMap and see if I can do a quick demo for you of the full motion video capability. And let me call up my project and bring this over onto the screen. So the full motion video add-in appears with a toolbar, and what I would do is call up the video manager with this toolbar. Unfortunately, I'm having trouble getting that view to come back onto screen. So let me try one thing very quickly and see if I can restore this. Otherwise, I may have to skip this demo and come back to it. My apologies. I lost this window just before we started, and I cannot seem to get that back on screen. All right, well, that's the way live demos go sometimes. Let me go ahead and continue, and if I can restore that before the end of the presentation, I can show you full motion video, or I may be able to call up a stored video with that FMV add-in. So let me go ahead and talk a little bit about drone data management. So the question now is if we have best practices or recommendations for working with the drone imagery to better manage your data once you've captured the data. ArcGIS enables image management using a data structure that we refer to as the mosaic data set. This is a database model that references all of the imagery in its original source data. So when on this first bullet where I say we reference the source data, what I mean is that the image pixels are not copied into the mosaic data set or into the geodatabase, but the mosaic data set simply references the imagery from the original files on disk, and that can work in any number of map projections on the fly. Mosaic data sets ingest the available metadata as well as any custom metadata that you may want to add, and more importantly enables the definition of a wide range of image processing functions to be applied to the imagery when the data is accessed, which is what we refer to as on-the-fly processing. The software also allows dynamic mosaicing, which means that when we create a mosaic, it's a virtual mosaic on screen, and you don't lose the overlapping pixels. So you can always bring different images to the foreground if you are using the dynamic mosaicing of the mosaic dataset. And then, of course, the mosaic dataset can be accessed as an image on screen, simply panning and zooming, but you can also access it as a catalog and search and select imagery according to attributes such as the sun angle or date of capture, etc. And this is something that I will show in a bit later. And this can be done directly in the desktop environment, or if you're sharing, it can be done through ArcGIS Image Services. So how does this apply to Drone to Map? If you're only doing a small number of projects and no follow-on imagery or GIS analysis, you may want to work only in drone to map. But note that drone to map does not really contain analytical tools, and the intent is to provide a front end to bring the data into your GIS. So if you're only doing a small number of projects, such as the example I have on screen, this may be all that you would need to use. And then if you want to share those projects, as I showed, you can actually publish that imagery as separate image services through the raster tile cache. But one thing to note is that in this case, I'm going to have 3 separate image services for my 3 separate projects. And if you only have a limited number of projects, this may be a very effective workflow. But since drones are becoming so widespread and easy to operate, but generally cover small areas, we're seeing a larger number of individual projects. You may fly several each month, but as the projects start to scale up, and perhaps some of these are multi-temporal flights over the same area, it can become a bit of a data management challenge. So we do have a recommended architecture to provide appropriate scalability in this situation. Our initial recommendation is to create a separate mosaic data set of each source collection. This facilitates QC and project management. And note, again, I'm focusing on drones, but in this scenario, you could apply this same architecture that I'm showing to satellite imagery or conventional aerial imagery as well. So for the orthorectified mosaics and digital terrain models that are output from drone to map, we can add those into single mosaic data sets. But then for the sake of simplifying user access to the data, in most cases it's preferred for users to be able to find all data in a single location rather than looking in different folders or computers or perhaps on a stack of USB disk drives. So the mosaic data set has a concept we refer to as a derived mosaic, which is a combination of mosaics into one master collection. And for those of you who do have technical expertise with ArcGIS, I want to stop for a moment and highlight this in the center, the table raster type. If you add mosaics as input into a mosaic, you want to be sure not to use the default raster type, but instead use this table raster type. That's important for scalability. And if you have questions, we can discuss that perhaps offline or at the end. The other note that I want to make is I'm talking about centralizing all of our image data in a single location, but I really mean all image data that appropriately belongs together. So in the case of drone imagery at centimeter resolution, this would be drone imagery. If you're managing Landsat data or elevation data, I would not mix those in with the drone imagery. I would replicate this same data structure for those different types of data collections. But then, once we have all of our data managed in a central mosaic data set, we can actually share that as a single image service. And now, instead of having multiple different services and filling up our server with a lot of server tasks, I've got one single image service that can be shared to desktop, web, and mobile clients. And then, of course, we can select different data sets by date or by any of the other attributes within the attribute table, and that enables searching and filtering. So that's something that I'll show in just a moment. And then one last thing I want to come back to is just to highlight that the products we get out of drone to map from frame imagery are going to be the orthorectified mosaic and digital surface model. We can also get the point clouds and 3D models. But there's some hidden value that I've highlighted with this red box, and that is the ad hoc photogrammetric process behind the scenes also will generate detailed metadata, whether nadir or oblique, for each of your individual photos. And that can have incredible value that I will show when I get to my demo. So let me show what this looks like when we actually manage and share one single image service with a large number of projects within that image service. So in this case, you're looking at an image of the Los Angeles Coliseum, And if I zoom in, you should be able to see the individual seats within the Coliseum. We can see the individual seats that are up and down, so you can see quite a bit of detail in this mosaic of the LA Coliseum. If I go to my attribute table, I can then call up different projects. For example, if I center on this project, this is an asphalt processing plant in Georgia within the United States. If I scroll down to the West Point project, this is the rifle range at the West Point Military Academy on the east coast of the United States. You may notice in my attribute table I've got a data set here in Abu Dhabi. And this is actually a school in one of the towns in Abu Dhabi. I must admit I'm not familiar with Abu Dhabi, so I've never been to this location, but this will give you an idea of where we're looking. And the key point that you're seeing in this example is that I'm using the attribute table of my mosaic data set to search for my different projects, but they're all coming from one single service that I've labeled orthorectified mosaics. Now, if I turn on my digital surface model, for example, these dirt piles that were captured for us by 3D Robotics, a drone company in Berkeley, California, we can also see the 3D surface models that were created by Drone to Map. But let me go back to the orthorectified mosaics and highlight our ability to look at different times. So in the case of this particular site, over these dirt piles, we actually have a different set of images from a different date. So by using the attribute table and changing the date selection, I can look at different dates within this same single image service. And once again, the digital surface models are coming from a separate mosaic data set, but all of my different projects are merged into that one single digital surface model. The last thing I want to show, if I close this attribute table, if I go back to the Los Angeles Coliseum, I'd like to highlight one other aspect, and this is something I have to be careful how I phrase this, because I don't want this to sound like there's a negative or a problem with drone to map processing, but with any tool you have to understand its strengths as well as its limitations. So let me focus on this car, and you may notice that this car looks like a bit of a phantom, and that's because the car was actually moving, and in one image of the source data that went into this mosaic, we captured an image of the car, but in other images that car was missing. And if I move around, you'll see some other examples. There's a truck here where you're seeing two phantom copies of the truck. So the bottom line is the mosaic created by Drone to Map is very good at a scale down to at least 3 to 4 times the native pixel resolution, but it does have limitations. As an example, if I want to look at this this vehicle that's used to lift workers up to a higher elevation, at this scale it actually looks pretty good. But if I zoom in and try to determine if that piece of equipment may be damaged, the way the mosaic is built is actually blending pixels from different images. So when you go to full resolution, you do run into limitations. And I want to highlight that by now showing you the single frame image that was used to generate that mosaic. So if my application wants to look at the resolution of the imagery here at about 4 times the native pixel resolution, the mosaic provides a very good synoptic view of my whole project. But if I need to look at something in extreme detail, such as this truck, or let's jump to these men who were working over on the side of the stadium. At this scale, you may be able to tell there were 4 men standing here, but if I zoom in, it's difficult to identify them. If I go to my single frames, I can now see with much more detail what was actually observed by the software, or I'm sorry, what was observed by the camera that was used to compile each of these mosaics. So once again, this single frame service that I'm showing is a mosaic data set comprised of all of the single images that went into my mosaics. So if I call up this attribute table, you'll see I've got over 2,000 individual images all being shared through an image service, so I can see all the detail of all the images that went into each of my mosaics that were captured and then shared through this image service. So I believe that's all I wanted to show in the example of the centralized data collection. Let me go ahead and show you where to find resources. We've got a number of resources to point to if you're interested in the methods that we use behind the scenes. So this short link will take you to a specific script that is used for managing the products of the Drone to Map software and to generate those 3 centralized collections that I was showing, the orthomosaics, the digital surface models, and the single frames. The starting point that's one level up above this link is this landing page, which is our image management workflows. And this is a location you can find information about how we recommend managing your data and applying the workflows, including sample scripts, which are available in this group in ArcGIS Online. So if you follow this link to this page in ArcGIS Online, you'll actually find downloadable samples and working scripts that can be used to replicate this management structure that I had referred to. And this Enterprise Image Management white paper actually provides quite a bit of detail on how we manage this behind the scenes and some of the basic concepts that you would need for working with imagery in this manner and working with the mosaic data set. So I ended up a bit short because of my full motion video demo. Jeff, if we've got some questions, maybe we could answer some questions, and I can see also if I can get that FMV demo to work.
Well, thanks, Cody. Yeah, if you would like to start that, I don't know how you'll do with answering questions while you try to sort that out. So
multitasking.
So good luck with that. How about I pick up the first question while you get that started?
Okay.
The first question is, there's a few questions actually came in about kind of getting started with Drone to Map. The first question was, how would we recommend getting started, and how do I go about getting a copy of Drone to Map to experiment with? Well, I think I can pick up the first of those. I believe, Cody, correct me if I'm wrong, but Drone to Map does follow into the normal product category of being available for evaluation. So if somebody wants to pick up a copy of Drone to Map, they should go through their normal account manager process, and obviously we're talking to the Middle East today, so presumably the software can be made available on an evaluation basis, like any other piece of the software. There's no restrictions that we know about there. Yeah,
that's correct.
So how about getting started? What would your recommendation be to get started? Is there any you just mentioned resources, but any training available? Do people have to be already pretty familiar with image data management? Obviously, if they are familiar with that, then perhaps they're going to be more comfortable with the data sets, but
they do not need to be familiar with data management. The Drone to Map software should be very easy to understand and use. There are tutorials available as well. I'm just calling up the landing page. If you go to Esri.com Drone to Map, you'll find the landing page. And again, outside the United States, I'm not sure if you can simply click this button. You would need to go through your account manager. But we can very definitely provide tutorial data and sample data. And our training department also does have training courses for Drone to Map.
Do we know if those training courses are available online?
Yes. Yeah, they should be available online for anyone with an ArcGIS Online account. But yes, there are typically some free courses that take anywhere from 30 to 60 minutes, but those should be available online.
That's good. And does drone, forgive me, I should know this, but if somebody has a copy of ArcMap or Pro, do they get a copy of Drone to Map, or it's an extension that they need to purchase, or do they?
No, yeah, it is not bundled as part of the core product. Drone to Map was actually developed in partnership with Pix4D. It is a standalone product. This is something I did not mention in the demo. You do not need ArcGIS installed to run Drone to Map. So it is a standalone product, but it also does require a separate payment.
Okay. So that's those couple of questions. So let's move on to there was a question asked about just clearing up Drone to Map you used for the image processing and creating the mosaic, but you used for the video, that wasn't Drone to Map, right? That was the full motion video add-in.
Correct.
So could you just please clear up the difference between Drone to Map, as you just introduced, separate standalone product developed with Pix4D. So I think we understand that now. But the full motion video add-in?
The full motion video add-in is a free product. So this is not built into ArcGIS. You do need to download and obtain the full motion video add-in, but there's no charge for it. It is a free add-in. It currently runs in ArcMap only. And actually, let me go ahead and put this on screen while we're talking. If you don't mind, let me go ahead and play this. This is actually just a recorded screen capture video of the Drone to Map, or I'm sorry, of full motion video capabilities. And basically what you're seeing is I can view the aircraft track and the video footprint on the map, and then I have a separate window that shows the video. And what you're seeing, the red overlay, is where I'm actually displaying features from my GIS within the video. We can actually capture features within the video, or we can display features from the map within the video. I can also capture individual rectified frames, although they're not ortho-rectified, but FMV does allow me to capture rectified frames. Let me go ahead and run that again while I'm talking. So again, full motion video is an add-in that currently runs in ArcMap only. It will be coming out in ArcGIS Pro in the 3D environment at the end of this year. But again, that is separate and different from Drone to Map. Now, I have had people ask about processing video through Drone to Map, and if you do capture video at a steep angle, meaning near nadir or at a nadir orientation, full motion video can extract frames from the video, and then those frames can be processed through Drone to Map. But in an example like what I have on screen, if the video is taken at a shallower oblique angle, then that does not work as well. It may or may not work depending on how oblique the angle is. So bottom line, full motion video and Drone to Map are fundamentally separate products, but both can be used with drone. Both may be applicable for your drone depending on the type of camera you've got.
Okay, that's great. Thanks. So a couple of other questions have come in while we've been talking. I mean, they kind of jumping around a little bit here. So back on the drones for a second from the video. If somebody's just getting started, any recommendation on drones? If somebody wants to kind of get their feet wet and start out with a drone, I'm not sure we make any recommendations, but are there some common drones that people are working with that can readily be integrated with Drone to Map?
Well, the good news is any any common camera should appear within the Drone to Map database. So nearly any drone that you would buy nowadays, the camera should be compatible. But within the United States, there's one manufacturer by the name of 3D Robotics. They make an inexpensive drone called the Solo. Those sell for about $1,000. I think maybe another $500 if you want to put a camera on. We've got a business partner in Europe by the name of SenseFly. They make a fixed wing called the EB that is very commonly used, and of course DJI, a company out of China, is probably the world leader in consumer drones. But at the more professional end, I would recommend SenseFly. They've got some very capable drones. There's another company called Ascending Technologies in Europe, and Arion Labs. That's AERYON, I believe. Arion Labs in Canada also provide very, very good professional drones. Those are more in the $25,000 to $50,000 price range, but for professional operations, they're very, very rugged and very capable.
Okay, great answer. So moving on to the data that's produced, a couple of questions about the coordinate systems that typically are captured. Mm-hmm. So could you talk just a little bit about the normal process if the drone is capturing imagery? How do we make sure that we bring it in a appropriate coordinate system, that we have a coordinate system kind of registered with that drone imagery? How do we make sure that it marries up?
Okay, well that's a very good question. There are several things to be aware of. First, when I create a new project, you'll see the default assumption for the GPS coordinates is that your GPS is in lat long WGS 84. So that's the coordinate system typically of the GPS data that is associated with each image, but that is not the coordinate system of the project. That's only to position the original images. If I call up the processing report, I did not show the processing report, and I may not be able to find it in this processing report, but by default, what Drone to Map will do will output your project in the UTM coordinate system that's most appropriate for your lat long. Now, so those are the two different coordinate systems to be aware of: the input imagery and GPS versus the output. Now, if you do want to use a different coordinate system, you can import ground control captured out in the field, and I would certainly recommend for any serious projects to bring in your own ground control points. So in this scenario, you would be able to define the coordinate system from a very, very long list of coordinate systems. So this would override that default of UTM, and this will allow any coordinate system within the ArcGIS platform to be applied for your orthomosaic and for your digital surface model. So I'm glad you asked that question, though. That's very important to understand. So if there's any more on that, let me know, but I hope that answers the question about coordinate systems.
We'll see if there's any follow-up. In the meantime, my friend Joseph over in Oman asks limitations on number of images that Drone to Map can process.
That's a good question. I don't know if we've actually found an upper limit. I know we have done projects with over 5,000 individual frames, but I honestly don't know what the maximum would be. You definitely will start to run into computer resource issues. The current version of Drone to Map, right now we're on version 1.2, and the current version of Drone to Map does not have the ability to split and merge projects together. But the next version, I believe that is going to be possible. So if you do a very, very large project, what I would recommend would be processing that project in blocks and then merging before outputting But I'm sorry, I don't really know what the maximum number of images would be for drone to map.
Okay. So I guess on a connected question, someone asked about from Abu Dhabi, asked about pipeline, the use of drones in pipelines. Of course, in many countries in the Middle East, there is a mixture of pipelines, both exposed on the surface and buried. There's a couple, I guess there may be a couple of embedded questions here. One is in relation to drones that can fly pipelines because they're long, skinny things. So obviously there may be some considerations in range of the drones. So
Right.
maybe you could speak a little bit to that. You know, fixed wing versus rotor and so on. And if drone to map can handle both types. And I guess there's also an implied question that, of course, some of these pipelines are buried and leaving ground disturbance and so forth. How detailed can the drones be? So would they pick up ground disturbance and stuff, or does it, you know, is that beyond the capabilities of the drones and so on?
Yeah, those are really questions. Many of those questions refer more to the drone than the drone to map software. But let me, excuse me, let me take those in sequence. I do not know the regulations in other countries outside the United States. In the U.S., we're still prohibited from flying beyond line of sight. So flying long corridors like pipelines or power lines that is still not common in the United States. In the Middle East, I don't know. That's going to be an issue of regulation. I think many of the drones you'll find, the inexpensive drones, say $2,000 or less, typically have a flight time of about 30 minutes. And I'm only guessing, but I would think you could easily fly 5 kilometers in that time period. But again, you've got the question of regulations and whether you're allowed to fly. And in that scenario, I assume you may just drive your vehicle along and watch the drone as it flies. But the more professional drones would be able to fly for a longer period of time. And I don't think duration is really going to be nearly as much of an issue. You were asking about following a linear feature. One thing that I think would be very important to understand is when we want to process images through drone to map, we recommend a minimum of 70% overlap from one image to the next. But that's assuming that you're flying in a grid pattern, something like this. The way the software works is it finds common points within the overlap of images to rigidly put the images together. But you're typically going to be flying a grid pattern, but in the case of a long linear feature, you don't have parallel flight lines. So I would encourage even more overlap, something like 80% overlap from one frame to the next, to make sure that we can actually stitch images together if you've got just one single flight line. And then your last question about detail, I think fundamentally that really boils down to the optics, how high above ground you're flying, and how fast a shutter speed you have. Typically for long duration, you would fly a fixed wing, but they're going to have to fly faster to stay aloft. And if you're trying to capture something with extremely fine detail, such as 1 centimeter, you may have no choice but to fly a rotary wing drone, a quadcopter or a hexcopter, so you can fly more slowly. So the key there, I could give you my opinion, but really the key there would be to do some experimentation with flight altitudes and flight speeds to make sure that you don't get blurring in your imagery. And that is something we typically do see. There's often some blurring, and from one frame to the next, if the drone is hit by a gust of wind, you'll often see blurring in one frame that wasn't in the previous frame. So hopefully that answers that.
Yeah. Well, I think the question there is some of the audience would like to see more case studies of drone usage, and maybe that's something that you and I can follow up on, because I know in our previous conversations we didn't have time for today, but to talk about drone usage in exploration scenarios, in pipeline, in health and safety, and so on. So we'll follow up with that. A quick question on 3D perspective views and support for to publish those views in ArcGIS Online. So if anything that I generate using Drone to Map, I can publish via ArcGIS Online?
Yes, yes. I did not show, I'm trying to remember, hold on, I think I may remember this project. If you were to create the 3D products, yes, this will bring it up. If you create the 3D products and then on the Drone to Map menu, I push the scene button, I can actually publish. So that's right here, publish scene layer. That will put a 3D scene on ArcGIS Online, and this is the asphalt plant that I jumped to very quickly when I was doing that demo of multiple projects. So here you can see the result. This is a scene layer in ArcGIS Online, and actually let me put that back on screen if anyone would like to look at this themselves. It's Esri url.com/asphalt, which is not an easy word to spell. Asphalt 3D. So if you jump to that URL, you'll get to this scene, and you can actually look at this scene in your own web browser. But so this is a 3D textured mesh where the imagery has been draped on top of the digital surface model that was generated within the photogrammetric processing. So did that answer what you were asking?
Yeah. Yeah. Okay. I think we're going to have to finish it up here, or else because we're out of time. But does that include video? I mean, if somebody captured video in a similar way, can they publish the video through ArcGIS Online somehow?
Not exactly. We're actually, I guess the simple answer is today, no. We are working on a capability for web sharing of video. It's not ready today, and it would not have the full capabilities of full motion video, the full motion video add-in. So the short answer today would be no, although hosting a simple video on YouTube is relatively straightforward. And then you could link that to a feature class on your map. But there's no integrated video sharing at this point.
Okay, and final question as we sign off: if Banu and others who are on the line if they are quite sophisticated with this stuff and do want to know more about the table raster functions that you mentioned,
yes,
what's the best way for them to follow up with stuff like that?
Well, the starting point would be to go to this second link, the image management landing page. That's here. Actually, I think I've got it on screen. I just skipped over it and didn't show it. This landing page, if you go to esriurl.com/image management, you'll land here. The tools are here. So if you follow this link, this will take you to the group in ArcGIS Online where we've got samples. But if they have questions, they can send an email to imagemanagementworkflows@esri.com, and that will get to me. Or we can share my email, which is just cbenkelman@esri.com.
And we'll follow up in an email there. So just last question as we close up here. Of course, we publish to ArcGIS Online, but we can make this information available through Portal, right? In the same way.
Absolutely. Yes.
Same deal. ArcGIS Online available through Portal too. So.
Yes.
All right. So we're just at the hour, actually just past it. So Cody, thank you so much. Thank you for everybody who attended. I have humble apologies for the poor audio at the start of this presentation. Don't really know what happened with the audio. So please accept our apologies there. Hopefully it was good for the rest of the session. Thank you for all attending. We look forward to hearing your feedback. If you have other subjects we'd very happily consider them for future webinars, and we'd be happy to follow up with any questions to Cody for the subject today. Thank you, Cody, and thank you, Eamon, for introducing us to the Middle East PUG chapter. This is Jeff signing off for today. Hope to see you all again soon. Thank you, everybody. Bye for now.